Today we are going to go for polar coordinates. I think you have an idea about polar coordinates. If you don't, I'll give you the idea about the polar coordinates. Okay. We know this is a Cartesian coordinate. We have x and we have y. This is, they call it Cartesian coordinate. أو المحاور الكارتيزية. Sometimes they call it rectangular coordinates. Any points in this rectangular coordinates or the Cartesian coordinates, any point, whatever here, this is the second quadrant, this is, we call it the first quadrant, this we call it the second quadrant, this is the third quadrant, this is the fourth quadrant. So if you have the point in the second quadrant, so your x is negative and your y is positive, right? So you should have here a negative value for x and you have a positive value for y. Okay. If you go for the third quadrant, both of them are negative. So negative x and negative y. For the fourth quadrant, your x is positive, but your y is negative. So you have positive x, but negative y. In the fifth quadrant, both of them are positive. Can you mute that sound, please? Okay. So this is a Cartesian coordinate. And we have different coordinates called polar coordinates. The polar coordinates, you have a pole. The pole corresponding to 0 and 0, right? So exactly like that one. And then after the pole, you have the polar axis, exactly like the x-axis. Okay. So first you have to measure the distance, what they call it r. And then after the distance, you have to rotate by the angle theta. So any point here has a coordinate r and coordinate theta. R is the distance from the pole, okay, to the point, and theta is the angle with this one with the polar axis, right? If you go to anti-clockwise, your theta is positive, but when you go with the clockwise, your theta is negative. Okay. Your theta starts from here, theta is 0, and end up here until theta equal to pi. If you go from with anti-clockwise. If you go with the clockwise, you start from 0 into minus pi, right? Okay. There is a link between the polar coordinates and the Cartesian coordinate. What this link is? As I said, the x-axis exactly like the pole, right? So if I have a point here, and this point has a coordinate, Cartesian coordinate a and b, so x is a and y is b. If I would like to have it in terms of r and theta, so this is a position vector, so this will be theta. Okay, how I can get the relation? If I get down here, so this point will be x, which is a. If I go horizontally, this one will be b. Okay, so I have a right triangle here with right angle and theta, and I know this a and this is b, which is exactly like this one because this distance is the same as this one, so it is b. So using Pythagoras, I can find the hypotenuse or water, which is a square plus b square. Okay, now If I would like to have x in terms of theta, so analyze this one. So x will equal to a cosine theta, r, x equal to r cosine theta. This is r, this is theta, so this is, if I call it r, and y will equal to r sine theta. This is if I have r and theta, I can get x and y. What about if you have r and theta, x and y, you would like to have r and theta? R is exactly a square, and theta is the tan inverse of b over a, because if you divided b over a, you will have tan for this angle, right? So r is root square is of a square plus b square, and theta is tan inverse of b over a. This is the link between the Cartesian coordinate and the polar coordinate. Good.
Doctor?
Yes.
I'm sorry for interrupting, but I joined late because I had technical issues. I'm really sorry.
Okay. So this is a Cartesian coordinate. You have a and b as a point. So x is a, y is b. As a point in the polar coordinate, you have two coordinates, r and theta. If I have r and theta, I can find x and y from this relation. If I have x and y, I can get theta and r from this relation, right? This is how to convert from Cartesian to polar and from polar to Cartesian. Okay? When we go for the area as definite integral, as we see, if I go from a, I know this area is exactly the integration from a to b for my function f of x dx, right? Yes, when I'm slicing this one, I'm slicing as rectangular, okay? So I can get this one a slice. What about if you have a polar? If you have a polar, you go and have delta x here. In this case, you will go for r and delta r, okay? So if you go in a very small area like this one, this is exactly like any one of the slide here. So you will have d theta here, right? And this is r and this is r. What is the area of this sector of a circle? The area is half r square d theta. This is the area of this small piece. So what I'm going to do, I'm just integrating from theta 1 to theta 2, okay? This will be the area in the polar coordinate. You said how I can integrate r with respect to theta. I said no problem. As you have here y as a function of x, and you said the area is equal to y dx, but you have y as a function of x. So this is exactly here. Your curve r will be a function of theta. This is how to find the area in the polar coordinate. Again, you know the Cartesian coordinate, any point has two coordinates, x and y. Also in the polar coordinate, you have two coordinates, r and theta. X is the horizontal distance, y is the vertical distance for the Cartesian coordinate or rectangular coordinate. If you go for polar coordinates, so you have r and theta. There is a link between them. Yes, r is this hypotenuse of the right triangle. So r is the square root from Pythagoras, a square plus b square. And theta if you divided b over a, you will give you the tan theta. So theta will be tan inverse b over a. This inverse function, not power minus 1. This is inverse function. This is why when you are using your calculator, you press shift and tan, or shift and sign when you have this notation, right? In the Cartesian, we know the area is the integration of y dx. You cannot integrate y with respect to x unless you have y as a function of x. This is what I have done in this definite integral. If we go for the polar coordinates, I will get a slice and sum all of these slices. So the area of small slice like this one is half r times r, and you have the angle d theta. If you sum them, the summation is the integration. So you integrate from what? From your start point here to your end point. All of this one depend on the theta, right? So I'll go start from theta 1 and end up at theta 2. So I can integrate all of this one, okay? Now I will go for the sum of the example, okay? Look at this one. This is a formula of the area in the polar coordinate. Okay. If you have two regions, like we have y1 and y2, right? Exactly. I will find the area of the higher one minus the area of the lower one to have the area between them, right? This is what I have done in the Cartesian coordinate. Okay. So, but remember, you don't have y and y1 and y2. You have half r2 square if r2 is the higher one minus r1 square if the r1 is the lower one. And you start with this angle from your start point, which is alpha, and you end up with this one. This your area end up in this theta equal to beta, and start with theta equal to alpha. So I integrate from alpha to beta. This is how to find the area under one curve and between two curves, right? This is a cardioid curve. This is look like the heart, okay? So they call it cardioid. This is why the doctor for hearts, they call it cardiology, okay? So yes, how I can find the area of this one? He gave me the function of this curve in the polar coordinates. R equal 2 times 1 plus cosine theta. So any point here has r and theta. R is given by this one. So if you know the angle, you can find the r. Okay. The area formula is half r squared d theta. And you start from half of the heart. So you start from 0 to pi. And then you get this half, right? Or multiply it by 2. Or you go for all of it in one go from 0 to 2 pi. It's up to you, right? So if you go from 0 to pi, you have to multiply by 2. If you go from 0 to 2 pi, you cover all the cardioid curve. How to integrate this one? So you have to expand this one. How to expand the complete square? The square of 1 is 1. 2 times the first time and the second, 2 cosine theta, plus the square of the second one, cosine square theta. Okay, now I have to get rid of the cosine square because I don't know what is the function I differentiate to have cosine square. I know the trigonometric identities give me cosine square is what? It's half times 1 plus cosine 2 theta. But don't forget, you have here 2 square, so you have 4. So you have 2 outside here. When you multiply this 2 inside, you have 2, 4, and 2 times the cosine square, which is half times 1 plus cosine 2 theta. Now, if I go for this one, I have 4 cosine theta, 2 times half will be 1, 1 plus 2 will be 3, and then cosine 2 theta, okay, because this 2 will be cancelled with this one, right? Now I know how to integrate any constant. It will be the constant time the variable here, theta. Plus 4 is a constant. What is the integration of cosine? Is sine theta. What is the integration of cosine 2 theta? Is sine 2 theta over the derivative of the angle. So I have to divide it by the derivative of the angle. What is the derivative of 2 theta? Is 2. So I have to divide it by 2. Now I substitute by 2 pi. I know sine 2 pi is 0, sine 4 pi is 0, but the only thing and sine 0 is also 0. So I will have 3 times 2 pi. This is the only non-zero value here. So the area of the cardioid given by this equation in the polar coordinates is 6 pi. Now if I go for this one and I'm looking for this area, right? This is the curve given in the polar coordinates. I know the formula for the area in the polar coordinates. Why he multiply by 2? Because you can, because of the symmetric of this one, so you can take half of the area and multiply by 2. Why I take it half? Because I know I can start theta here is pi and theta in the beginning is 0, okay? But if I take half of this one, I can start from 2 pi over 3 into pi, right? What is 2 pi over 3? What's 2 pi over 3? What is the angle of 2 pi over 3? 120, right? And he already gave it to you here, right? So you will start from this one, okay, to that one. So you start from here and you take the half, okay? And then you multiply the area by 2. So this formula is for half of the shading area that he's looking for. Now I'll go and substitute for r squared. I have done the same thing. I substitute cosine squared by half times 1 plus cosine 2 theta. It is better to have a margin and do your simplification, and then you substitute in the formula here. This is the area here from 2 pi over 3 into pi, and you have 3 times this one. So once you finish, you get the area here, okay? So you multiply it by 2. Don't forget to multiply it by 2. Okay. Now you have this nice shape, but you have two curves in this case. So I have to remember, when I have two curves, I have to check which one is the higher one and which one is the lower one. And don't forget the formula having half. So half will be a common factor. The higher one squared minus the lower one squared, right? This is the area in the polar coordinate. So yes, which is the higher one? R2. With the lower one is R1. So I go for the area will be half R2 square minus R1 square. What is my boundary? I will start from here, right? My area starts from here. What is the angle here? I am anti-clockwise here, so my theta is minus pi over 2. Here, and I measure this one here, it is positive pi over 2. So I can integrate from minus pi over 2 to pi over 2. The integration from minus a to positive a for any function, it will equal to 2 if it is even function, or because it is symmetric. So you can take half, and instead of integrating from minus pi over 2 to pi over 2, you can integrate from 0 to pi over 2 and multiply it by 2. Okay, very similar to what I have done over there. I also replace the cosine square by half times 1 plus cosine 2 theta. Okay, so I will have this answer here. Once you reach this one, you can do it by the calculator, right? Even from the beginning here, you can do it by the calculator, but you have to know how to do it by hand. Okay. Now I will stop my recording and we will start to solve this question. Okay. I will put it in the chat and anyone can solve any question he would like and would like to share with us and to see it is right or wrong, he is most welcome or she is most welcome. Okay? If you don't understand anything, please ask.